These are the video notes that's going to go with translating direct variation problems. Okay, so our central question of the day is, how do I translate direct variation problems? Okay, so let's back up for just a second. What do I mean by translate? Translate means to typically take something and put it into another form. Most of the time we think about the word translate, we're thinking about from one language to the other. Okay, for our purposes this time, it's going to be taking a table of values, a graph, and an equation. And if I'm given one of those three, I'm going to be able to give back the two matching items that go with it. Okay, so if I look at number one right here, it says here, using this table of value, find the following. So let's look at this table of value really quick. Okay, so if I notice my headings right here, it says input, output, which we are comfortable with. That's X and Y. I also notice I have four ordered pairs, 0, 0, 1, 3, 2, 6, 3, 9. Okay, so I have four ordered pairs in my table of values. Okay, now my first question right here says, what is the input output rule? Now in elementary school, that's what you called it. But in our mathematical world, we don't say that. We just say, what's the equation that goes with it? Okay, so I'm going to have to look at my pattern up here. Am I adding, subtracting, multiplying, or dividing the input to get the output? Well, you can quickly see that this is a multiply by 3. How do I see that? Well, it's hard to see with 0, 0. Look right here. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. Now, you guys learned last year that your equation has your x and y's in it. So I'm going to have y equals 3x because I'm multiplying x by 3 to get y. Okay, that's a review from your proportionality unit last year. Okay, now, so we just translated this table of values into its equation. The next thing I want to do is translate this table of value into its matching graph. Okay, so I'm going to have a little piece of graph paper right here. And all I'm going to do is graph these 4 points. So let's see, 0, 0, 1, 3, 2, 6, 3, 9, right here. I'm going to connect them and put an arrow on either end because it is a line and it's going to go straight in either directions towards negative infinity and positive infinity. Okay, so we just took that table of values and we translate it into an equation. We translate it into its graph. Now I want to stop right here and talk about some more vocabulary. Okay, because our directions up here told us that this was direct variation. Okay, and you're scratching your head saying, I don't know what direct variation is. I've never done it before. Oh, yeah, you have. You just haven't used that vocabulary word for it. Okay, when you are in middle school and you're doing proportions, you're doing direct variation. It's just not called that. So look right here. Why is this type of pattern called direct variation problems? Because last year you called this a proportion problem. Okay, well, the reason it is called direct variation, number one, is that it is proportional. With that constant of proportionality. Okay, So, and there's a second part to this. It must go through the point 0, 0. That is a key component. Okay, so for it to be a direct variation, it has to be proportional, just like you learned in 7th grade with a constant proportionality. It also must contain the point 0, 0 in its table of value or its graph. Okay, now I want to connect a little bit more right here, where it says, what is the direct variation formula or equation? Okay, you were taught in 7th grade advanced math y equals kx, where k is your constant of proportionality. Okay, I'm going to abbreviate right there for a second. K is that constant being the number that you're going to multiply by. Okay, K is still legal, even in all the way up through way past calculus and everything. K is still legal to say constant of proportionality. But there's also another way to say it. We can say y equals mx, where m is called the rate of change. Now, we talked earlier this year with our recursive pattern that said rate is a word we used when we were multiplying. Okay, we used that with our recursive patterns. Rate means to multiply, and it's the number you're going to multiply so that it's constantly changing. Okay, this is the one we're going to use mostly this year, though. Okay, y equals mx. But I do want you to understand that k and m are really the same thing. Okay, k is your constant of proportionality. But so when I use the word K, letter K, you are going to say constant proportionality. If they use the letter M, and it is lowercase in both situations, use a lowercase m, you don't say constant proportionality, you read it as the rate of change. But again, third time, they are synonyms. They mean the same thing for us. Okay? Now, our first example, we took that table, remember, and we turned it into an equation and a graph. Let's see if we can kind of reverse the process a little bit. Okay, so let's look at example 2 right here. Example 2 right here says, I'm going to use the equation y equals 2x, and we're going to find a graph and a table of values with 4 data points. Well, I'm going to start with my table. Okay. Now, I can pick any number for x I want to for my table. But I'm going to pick numbers that's going to fit on my graph paper and numbers that are easy to work with. So the numbers I'm going to pick is 0, 1, 2, and 3. It says I need how many of them? 4. There's 1, 2, 3, 4 numbers. Okay. Now, that's my input. To get my y, my output, what am I going to do? I'm going to multiply x by 2. So multiply each of these by 2. So 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. 2 times 3 is 6. So now I have translated that equation into a workable table of values. Now, let's take that equation and let's turn it into a graph. So let's graph our 4 points. So we got 0, 0, 1, 2, 2, 4, and 3, 6. Okay. I'm going to connect them. I should be using a ruler, and I don't have one handy. Okay, and I'm going to make sure I put arrows on each end because it is an equation. It doesn't have a definite beginning or ending spot, so it can go from negative infinity to positive infinity. Okay, again, translating just means to take something and put it into a different form. So I took this equation and turned it into a graph and a table. Now notice I'm not answering any questions. That's not coming. That's not today. We're not answering questions or anything. We're just translating. Okay. Now, number 3 is what if I give you the graph? Okay, because we've done a table. We started with an equation. So now let's start with a graph. Okay, so right here is my graph. And I apologize for the ink blot right there from the printer. Let me darken my points here so we can see them. Okay, so I have this graph. I need to make a table of values and write the equation. Okay, so let's do the table. I'm going to do a horizontal table right here. So X and Y. Now, we've got a bunch of points here and I can list them all, but let's just do 3 points this time. So my first point down here is 0, 0. The next point I have is 1 and 20. And my next point right here is 2 and 40. When you do a table value, you want a minimum of 3 points. Okay, we got 3 points, so we're good. Now, what is my equation? What am I multiplying X by to get Y? Well, 0, 0, that's hard to see, but it's perfect to see right here with the 1. 1 times 20 gives me 20. Well, let's just double check that. 2 times 20 is 40. So, yep, that looks like that pattern works. So, my equation over here is Y equals 20X. And there's my equation. Okay. Now, make sure you have all these notes copied and they're in your interactive notebook and you can work on your assignment in Canvas.